So I'm Kyle, and together with Charles, we'll be talking about how to secure and share sensitive information. Before I start, I want to show of hands. I want to know my audience. I want to know who wants to testify in Congress for leaking information. Please, show of hands. Yeah, we have a taker. Fame and fortune above all. Okay, maybe who wants to go there because you forgot to encrypt your database? And then the biggest hack in consumer history here. Okay, the next one is easy. If you have operations in Europe, who wants to comply to GDPR? So yes, of course. Great. So why companies fail? First, data silos. That was precisely the case of Equifax. They have the same information across many databases. And once you have multiple data silos, you have multiple places to enforce security. And as well as we saw this morning, if you have many ETL tools, many different tools that you're transforming data, and this schema keeps changing, it's really hard for you to keep enforcing security in a standard manner. And then there is the ETL tool, the different database tools, all the tools that you have to learn in order to enforce security. What we propose here in MarkLogic is that in order for you to secure and share sensitive information, the first thing that you need to do is integrate that data from silos into our database.
I'm on.
And once you do that, our database is ready for schema changes, and I'll talk a little bit about how our security features can help you even if your schema is changing.
I do.
And you can enforce policies in a single place. So all your downstream applications can now have curated data, and you can control access to that sensitive information. So you can enable sharing of any information. We want you to be able to share the information, and if needed, hide that sensitive information. To explain the features, I'll use the Data Hub. We saw this morning Gary and Joe talking a little bit about that. So I would highlight a few areas of our Data Hub. It works in the database, but since this is the way going forward that most customers will be deploying, we will use this as our backplane. So I'll first talk about the access. So everything that is going out of the database will go through the access layer. I'll talk first about how to control access to the information. I'll talk about controlling access to documents and then to information inside documents. Next, I'll talk about what if you want to actually export data out of the database. For instance, for an analytics tool that you need to do, a business analyst wants to do some analysis. I'll explain our capabilities that allow you to redact and transform that data in a way that is safe to share, but still relevant to do data analysis. Charles will talk about enforcing policies in our curation of the Data Hub. I'll explain a little bit about the underlying technology, and he will show an application using the model-driven security. Finally, I will wrap up with how we secure data once the data is inside the database and is at rest at the database. So let's start with controlling access to the information. The basic thing here that we will start with is controlling access to the document. So in order to do that, two simple questions: who's the user and what the user should see or do? For that, I will explain our role-based access control. It's very basic for those that already understand MarkLogic, but I will revisit this. So I have my example here, two users. They have two separate roles, the compliance and the call center. And I have that insurance policy that I am applying some permissions. So for instance, the compliance has the permission to read and update, and the call center has only the ability to read. In the basic model, as I have highlighted there, it's an or. So or I have the compliance or I have the call center, I'll be able to read this document. We also have an advanced way of using this, which is called compartment security. Let's say, for instance, my use case is that I have an insurance that is in US and another that is in UK, and because of regulation, for instance GDPR, that cannot be exposed outside UK. So in that case, I will create what is called a compartment. And in my example, the compartment is the country. So now I create this role, the US and the UK, and I thought they are part of a compartment. When I apply the permissions to the documents now, to the insurance policies, I'm saying this call center can read and US can read. But because the US and UK are part of the compartment, now I'm applying an AND. So I need to have both call center and US in order to see the US insurance policy. I can create as many compartments as I want to in order to ensure not only country, but other types of regulations that these documents may be subject to. So this is the entire document. But what about information that I have inside the document? So how can I control, for instance, a piece of sensitive information inside that document? So first is, how do we identify that sensitive information? And how do I ensure this works across the product, even across search? For that, we'll be talking about role-based element-level security. Element-level security works across XML elements, but also JSON properties within the documents. And as I highlighted there, it's role-based. Based on my role, I'll be able to see or not information. Think about an extension of the document. So the document is, if I have that role, I can read the same thing here. I'll explain in details. Very important, this is out of the box. So many customers have tried to implement solutions like that at the application layer. It's very hard, I'll tell you. It's very hard. We implemented this at the database. We spent a lot of time ensuring that this is in the database, is high performant, and you don't have to have your developers thinking about this type of security. Just leverage the capabilities. And this is real time, and it's across all the access layer. So it's across search, queries, and updates. And this is ready for document schema changes. It's based on the concept that we call a protected path. And there is an XPath expression. It's easier to go through the examples for you guys to understand. So my first example, I have a social security number. The element is called SSN, and I want to protect that element. By using these double slashes here, it's telling it anywhere in this document schema, doesn't matter where it's nested. If I find that, that element, I will require an HR role in order to read. So even if I keep changing my schema, keep enveloping, if it finds that, I will require an HR role to read. It can be a little bit more advanced. I'm actually using information inside the element attribute, the access, to tell if I find this element and it has access that matches USA, I will require a USA role. And the typical example here, coming from government, if the classification is top secret, I'll tell I require a top secret role. And just to exemplify, I'm showing updates. It could be just for reads, but my example here is saying it also protects against updates, which means somebody can see something but not be able to update that element. Very common in the government scenario. And this also has the concept of ands and ors. Let me explain how an or works. But let's start from the bottom so it's easier to understand the problem that I'm trying to solve here. Let's say I have this agent, and I'm telling that in order to see that, it's releasable only for people that are from US, Great Britain, or Australia. So that's how this piece of information is classified. You can think about departments in the company or projects, but what is important here is the information itself is describing how it should be protected. We didn't invent this. This is actually a standard. It is a government standard. It's the NIST 800. But it's also, there is a standard for healthcare now. It's part of HIPAA. It's in review, but it will be the same concept. You will describe in the information how the information should be protected. And MarkLogic can actually leverage that. So I have here 3 protected paths. I'm saying if it contains USA, I will require USA role. So, OK, there will be a match here. The second, if it has Great Britain, there will be a match as well. So all these 3 expressions will match the same element. But because I included them as part of a set, I just added that property is a set, it will treat this as an OR. If I did not include that, it will force an AND, meaning I have to have all 3. But we allow you to figure out, given your policies, if it's an OR or an AND. It's very flexible, and you can combine in any way, so you can have ANDs and ORs according to the policies. But I think the most important thing, this is leak-proof. It's done at the database, and it's high performance. Let me explain how it works. When we ingest the document, Let's say the word secret matches a path. Right? It's telling I need to protect that secret word. And it's saying that in my path, it required the top secret row. At ingestion time, we will index that information in a different way. We will hash both the permissions and the term. When there is a query, and my query I'm running as an unclassified, that is what the URL stands for. When that query comes, we will expand the query, and it will hit the indexes. Because my row is different from how the data was indexed, there will be no matches. I cannot find anything. If I type secret, there will be no matches. I cannot find the information. And this is all real time, enforced at the database. Again, leak proof. But when I try to get the document, we will remove the entire element. The element is gone. I just get the non-sensitive information. So think about trying to do this at the application layer. It's pretty hard, so rely on the database, and every application that consumes data from the database will benefit from this capability. Okay, so we talked about document, and then we talk about information inside document. This is all real time. This is all query, search, and updates. What if I want to share? I want to export data out of the database. Some use cases here. First, I want to have a data dump for testing. Or I want to give data to data analysts. We saw a little bit about Hadoop. Let's say you want to send data to a Hadoop cluster to do analysis. Do you want to send the social security numbers and all the information about the users? Probably not. But you need information that is useful. And we'll talk about how to make that useful, but still remove the sensitive information. And finally, I want to do performance tests or user acceptance tests. I need data that looks real, but it's not real. For that, we'll be using rule-based redaction. Here's my original document. And I have two use cases here. The first is I'm doing an export for a BI tool. And the other, I'm doing the export for the QA and dev. What I'm doing in the middle, I'm just removing the names. Why the data scientist needs the name? He does not. All right, so I'm removing the names. And as you can see here, the social security number is different. Well, let's say I want to count how many insurance policies I have. Typical primary key, social security number, right? So this data scientist, he needs a primary key. But you don't want to give the real social security number. We allow you to do what is called a mask deterministic that will have a one-to-one relationship. So he will find my social security number in a different format. Let's say I have 5 insurance policies, but he has no access to the real number. I'll explain a little bit in more detail in a second. So he can do all the analysis. For instance, how many insurance policies I have, how many insurance policies exist in New York, but he has no access to my private sensitive information. Really good for, I want to send to the Hadoop cluster, for instance, do some, or any Tableau BI tool. The next example is for dev or QA. At that point, you're not doing analysis. You just need some random data that looks like real, but it's not real. Everything out there most of things are coming from a dictionary. It looks real. If somebody's testing and figuring out and doing queries, names look real, addresses look real, and we can even keep the cardinality. So if you have 10 times New York City, it will translate 10 times to San Francisco. So if you are trying to do some performance, you can pretty much do the same performance analysis, even if you search for San Francisco rather than New York. So we keep the cardinality, which may be important for tests. Very flexible in what you can do, and I explain about the functions. All out of the box, and again, this is done in the database. It's done in the database by creating rules. The rules will have the same concept that we saw before, is how do I find the information? For instance, let's say I want to find the client ID. And my expression is the policy client ID, and I'm telling what is the function that I want to apply. Mask random. Okay, why random? In my scenario here, I'm generating data for developers. Do they need real data? Probably not. But they need some data. They need to test some queries. They need to ensure that it's working. So some random data will be enough. So my scenario, I created some rules, and I added them to a collection. I call the collection developers export. You can reuse the rules and add them to different collections. When you redact, you just tell apply this collection. Remember my first example, I have the BI export. It's a collection of rules. I had the dev export. It's a collection of rules. You just apply those before you export data. What are the functions that we have out of the box? The simplest one is just conceal, just hide, as I did for the name for the BI export. Hide the name. There's nothing that needs to be there. But we also have functions like mask for random, deterministic, and dictionary. So random we already saw is just a random number or a random alphanumeric or alpha-only field. Deterministic. Deterministic is when I need to do joins and aggregates. I need to ensure that information is consistent within the export. Again, the social security number. I don't want the real social security number, but that's my primary key, so I need something that has that relationship within the database. And the dictionary is, as I used some random names, some random addresses that I will generate when I export the data. We spend a lot of time to ensure this is very secure when you use deterministic. And let's say I'm masking something deterministic, and we have all those capabilities about salting. MarkLogic is a fantastic database to integrate data. In fact, MarkLogic is a fantastic database to do a linkage attack. You can get data from multiple exports, use MarkLogic to join them, and use agile mastering to go back to the real information. We spend a lot of time to ensure that it's really impossible to do that. So it's really safe to export data using mastic deterministic because we have these two ways of sorting the data. So you get one export, you cannot join with the other export, but the export itself, you can do analysis. And even if you want, you give one export today, the next export that you give to the same person, he cannot join with what he had the day before. It's very flexible, but ensures that I can do my analysis, but it's secure. I will not explain in detail, but at the end I have a linkage to a blog that I wrote about what is a linkage attack and how it works. The other thing that we can do as well is find patterns in the data. Like I want to find a social security number even within a text. Let's say an element that has some text. I may have some social security number. Those things will find phone numbers, social security numbers, emails, IP addresses, or even any regex expression, dates and numbers. These functions, they actually work in two ways. First, they can find the information that you want to maybe partially mask, as I have my example of that. But they can also be used to generate fake data. So you can generate fake social security numbers, fake dates, fake numbers. Again, very useful for a dev or QA export. And if these functions are not enough, you can write your own, and it will be executed in the database before any data gets out of the database. Okay, so I talked about document, subdocument, and sharing, exporting. When I was talking about subdocument, we saw all those expat expressions. And maybe folks in the audience said, well, that's pretty advanced. Charles will talk a little bit about using a model-driven security approach that simplifies a little bit that. And given that you have a canonical form and entity, you just tell what is sensitive information, and automatically the rules will be created by you. If you have an advanced use case, go down and use the expat expressions, but the model that I will demonstrate, it's simplified and covers many use cases. I'll come back at the end to talk about encryption.
Thank you, Kaya. As Kaya said, we're going to see a little bit of a demo of what we're doing with element level security right now with regard to the Data Hub framework and entity services. What you'll see here is not a demo, it's a demo I cooked up, but all the code will be available to you in Data Hub Framework 3.1. So anything you're seeing here, you can do yourself. The idea is that although you've seen how to configure element level security and secure whatever you want to in a document, that use case might be more complicated than what you really need. So we wanted to simplify it, present one particular use case, and then make it really easy for you to do. So what you'll see in this is our story is that we just have some personally identifiable information, in this case a social security number. And the story is about a call center where you have two different tiers of people responding to calls, one of whom is a compliance officer. That person actually has to verify that the person on the phone is who they say they are. So they get to see the social security number and verify that's who they are. But another person, say a clerk, shouldn't be able to see that at all. In fact, they must not be able to see that personally identifiable information. In our scenario, a Java developer has been given a task: implement a get customer history function. Go write that function. It's going to get back anything having to do with a particular name. But if it's a compliance officer seeing it, they can see the social security number, but if it's anybody with less restricted access, they shouldn't see it at all. In fact, I'm going to give you another function, get customer history by SSN, that'll show you that even on a search, the compliance officer will be able to find people by SSN, but the other person won't be able to find that at all. Now, this is a model-driven scenario. Last year, we introduced a feature called Entity Services, where you can actually define your own schema for documents. And we're slotting this new PII feature into Entity Services. So you do a model for your customers or your support calls or whatever, and inside that properties block shows that they have ID, full name, all these kinds of things. You can generate indexes from Entity Services, and then now in 905, actually, if you can find it, you'll see that you can add this PII property specifically to safeguard personally identifiable information. It takes an array, and in this case, we're just going to protect SSN. And then the Data Hub Framework tooling takes care of the rest for you. It's actually going to configure the security for you. I've been throwing around a lot of terms, so just to go over what I've said, when I say PII, personally identifiable information, this is probably something most of you are familiar with and want to secure, and it's a pretty well-known acronym in protection now. The Data Hub Framework, if I say DHF, I'm talking about the MarkLogic Data Hub Framework. You've seen that all over MarkLogic World so far today. You can go download it, and 3.0 just came out last Friday, so you can get started with your data integration. What you're seeing here is going to be in 3.1. ES, or Entity Services, that's a feature in the server which has all of the modeling vocabulary, how to define your types, how to define properties. And when you use Entity Services to define models, it decides what your documents look like. It's going to make documents conform to your models. That's what makes it easy for us to take a declaration of a model and then know how to secure various parts of it, because we're deciding what the documents look like, not you. And then lastly, ELS, element level security, is the feature underneath this. We're generating configuration for element level security, and that's what's actually going to protect your documents in two different ways. A protected path, that's the XPath expression that you saw Kaio demonstrate. That's actually securing what you see when you get a document back. And then a query role set is how the query mechanism controls who can actually search for different things. So this demo will take care of both of those things. Okay, just because I can't actually jump into a demo, I have to work it up and make it exciting as possible since it's after lunch. What have I already done? I created a test data set. I made a model for my support calls, employees, and customers. I implemented the get customer history function. And by the way, if you have a chance to see Eric Henham's talk about API first, I used his feature to make this get customer history function. I was probably his first customer, and I think it was a fantastic way to implement functions without having to deal with the API layer in between you and the database. I could just implement a Java function, and it works. I created some DHF flows and ran them. And then I defined a couple different roles. I defined a clerk. That's someone who can read documents, but not PII information. And then a compliance officer who can read the secured information as well as the documents. The steps I'll take. I'm going to actually use Quick Start today. When I originally started, I used just an editor to do PII, but you'll get to see Quick Start do it today. I'm going to indicate which property is PII. And then I'm going to, Quick Start actually generates that security configuration for me. An alternate is to use these Gradle commands to do so, but I'm going to skip those first two. But after I've created the security configuration, I'll go ahead and deploy it to the server and then verify what I've done. And under the hood, what's going on is this hub generate PII command. That's the Gradle command that I won't use in the demo. But the idea is that if I know where a property is inside of an entity services document, I know how to protect it. We're actually shipping a role in MarkLogic 9.0-5 called PII Reader. This is a convenience for you. If you have a simple scenario like this, you can use PII Reader to secure your PII information. But even if your security situation is more complex than that, this will give you a starting point for understanding how to take it from there. So when I run hub generate PII or do the equivalent in Quick Start, what's it doing? It's looking at all the models in my project, and it creates a protected path configuration for each of the PII properties and secures it with the PII Reader role. Secondly, it creates a query role set for accessing those properties in search with the PII Reader role, and then it saves these configurations into the DHF project. And then once those are saved, I'm going to use a Gradle task ML deploy security to take the configurations and throw it up to the server so it's actually implemented. So with that said, let's see if I can make the machine. I'll exit out of this view. So here's my Quick Start application. You can see I've loaded some things already. I have to turn around and try to do the backward pointing thing. Let me get out of this. There we go. So you can see that in my entities view, I have a couple different ones. Employee, support call, customer. And customer is what I'll secure. And you can see if I browse the data, I've already got some data loaded into my staging database, and it's also been put into the final database. Here's the document, just so you can see what one looks like. I've got a support call. That's right here on line 6. And then down from here, you can see the person who called is the customer, full name, and here's that social security number that you shouldn't be seeing right now. And then you can see who answered the call and who the compliance officer is for that. Let me pull up a shell, because nothing's fun without a shell. And then let me move the shell so you can see it. There we go. Is that big enough? And move everything out of the way. So the first thing I'll show you is just this function that I've implemented. Here is a clerk doing a query. It's at the very bottom of the screen. Can you see the bottom of the screen? Okay. Okay, well, I'll scroll up after I run it, and then you'll see it. So I run get customer history. It takes a little bit of time because I'm using the build tool to actually encapsulate the call, so it's a little bit slow. And I don't see anything at all. This is my response. That's because I have not given the clerk the role to actually see anything at this point. The idea is that it should be secure at the beginning. But if I look at an officer, I'll change this role to officer here and search for the name Carter. And now I should see something. OK, so there's the whole record with the social security number and everything else. And it's actually extracting just the customer out of one of those records. So I'll go back over to Quick Start, look at my entities, and I'm going to edit the customer entity. If you were to get 3.0, you would not see this little lock here. I wish everything were higher because I'm at the very bottom of the screen. But now I can click on social security number and protect it. That's all it takes. And I'll save the configuration. And I'm done. Behind the scenes, what has happened? And I'll just leave that alone. If I look at the plugins, entities, customer, this is my customer entity definition. And you can see that now that I've edited it, there's actually an SSN inside of this property. And moreover, if I look inside of user config security, there are 2 new directories, protected paths and query role sets. Now, I should have showed you those weren't there before, but maybe it wouldn't have worked, so I didn't want to do that. But they weren't there before, you can believe me. And inside there now is a configuration for each of the paths. This is going to have the configuration for SSN. I do want to edit the clerk role. This is the clerk who's been deployed to the server, but remember, this clerk couldn't see anything at all before. So I actually want to add the harmonized reader role to this guy. The reason I'm doing this is because in the DHF 3.1, anything you've harmonized will have a harmonized reader permission on it, so that you have a stock way just to read documents. So when I deploy this security, all of a sudden the clerk will be able to see things, but it'll also deploy the PII configuration. So ML deploy security should do it. That's going to send the clerk definition, sends all the definitions, all the roles up, and then it's going to send all of those protected paths up and the query role sets up to the server. So now everything should be secured. Do you believe me? Let's see if the demo gods believe me. I'm going to go ahead and run get customer history again using the officer. Nothing should change, right? The officer still has the same access. And then, but now if I search with the clerk, you'll see that the SSN is gone. Now, I could be doing this in the application tier. I don't like to hand wave and just tell you that I've done things. So I'll search for SSN as well. If I search by social security number, with the clerk, shouldn't see anything at all. Did it come up? Nothing. No results. However, an officer can search by social security number. And I should get back the record. So now you've seen that inside the database, I was able to declare that one particular property was a social security number, protect it from reading in the database, and then protect it from searching. And this is the result when you do that. Thank you. That's my after lunch contribution. So we'll go back, wrap up with a little bit more about encryption at rest. It's at the beginning of the... F5.
Okay, so we learned about document security, sub-document security, sharing information, how to use our entity services to declare information that you want to control access to. But what about the information that is in the database? There's information there lying on the disk. How can I ensure that that information is secure? How can I ensure that I can go to the cloud and be certain that my cloud admin cannot see that information? Also, I may have information that I want to ensure that it's not modified outside the database, or it's precisely the logs about everything that is happening. MarkLogic can audit every access and every modification to configuration and to documents. How can I ensure nobody is going and erasing traces of wrongdoing? I modified a document, I go there and delete my modification from the log. For that, we implemented advanced security. It's transparent encryption, which means no modification to application code, and it enables you to encrypt data, logs, and config files. And we support two models of managing keys. My illustration, I have the local key or the external key management system, KMS. And since we enable you to encrypt the logs, it ensures that whatever happens to documents or configuration, nobody can go there and modify. Very important for complying to regulation. And the number one question, what is the performance impact? It's very low, and the performance impact is mainly during ingestion of documents, because that's when we are writing documents to disk. And it's very low, single digit. We had performance tests running in cloud that were 2 or 3% performance degradation during ingestion. That's pretty low. So why it's low? Because these days, encryption is done at the hardware level. The chip actually does encryption for you. So as long as you are in modern hardware, very low performance impact. Query performance impact is negligible because we are not reading too much from disk. We are resolving from indexes in memory. And we took an approach that it's very secure. And I will exemplify here with the key management system using an external key management system. Once you want to open the database, what do? We will go and send what is called an envelope to the external key management system, and you receive back the fast rotation key. If that KMS does not authenticate with the database or is not available, you cannot open the database. We never hold the green key, the data key, in memory. Never. Other products actually hold the key. We don't do that, so it's very secure. If somebody compromises the memory, will not be able to get the master key that can do everything. So it's very secure in that way. And it's a different approach, and it's very novel because it leverages the latest edition of KMIMP 1.2. So any KMS that supports 1.2, we can work with, and we have certified few. Tomorrow, during the lightning talk, we'll actually prove that this thing works. We'll see a demo that it's impossible to reuse the data if you do not have access to the KMS. We'll show that working with the Amazon KMS, which is one of the KMSs that we support. Okay, concluding. So I emphasized a lot security in the database. The fact that many of the things that we talked about, you could potentially implement at the application layer. But there is room for mistakes. It's then another layer that can have problems. Or going back to my initial problem, it's a silo there. That application may be different from another application. It's much better to do at the database level. And we cover the granular, the document, the subdocument. As I mentioned, everything that happens is audited. We can guarantee that those access to documents and modifications to documents, since they are encrypted, cannot be modified. We talked about different ways of controlling access to that sensitive information, the rules in protected paths or the entity model. And we talked about the last piece, which is encryption. And Charles talked about governing. Once you create the entity and you annotate the entity with, okay, what is PII? So it's much easier to govern your data because you created the canonical forms and you're telling right there, this is sensitive information. And we even saw a really nice graphical UI to control that. With that, I would like to highlight some resources, some white papers that we have. As I said, I wrote a few blogs about all the features that we saw here. Charles has the entire GitHub project that he will make it public. And if you really want to understand about linkage attacks, there is a blog that I explain what it is and how we protect against that. Thursday, there will be a workshop. There are still some spots available. You can have hands-on experience with the capabilities, learn about document security, compartment security, element level security, redaction, and there's another feature that I didn't talk about, compliance security as well. With that, I will open to Q&A. Yes?
How do we put alerts on the audit log? So there's a threat happening on the sensitive. So there is an audit log, right? So there's a threat intrusion into the data layer, and then they're trying to read the sensitive data. Even though we are doing audit log, but we want to real-time alerts going to somebody monitoring, they will shut down the database. Basically creating the alerts to monitor.
Yeah, so MarkLogic can be used, the alerting capability of MarkLogic can be used to monitor logs, and we actually have implemented solutions to do that. So it's kind of a MarkLogic on top of MarkLogic. You're kind of loading the logs into the database, and using alerting. We actually do that. Tomorrow in the lightning talk, we'll talk about Ops Director. That's how Ops Director works. It's actually monitoring the logs to find issues and doing alerting. You can do that as well with MarkLogic. It's actually a fantastic tool to generate alerts on top of log streaming.
So question about the example that you had around protected paths. When we looked up there, we had a using XPath that was going to an attribute expression of like which country. Is protected path able to be used against attributes outside of XML, or is it XML specific?
It could be a property. The ones that I showed are using attributes, but it could be a sub-property. Okay. You just have to be careful because the XML document model is not the same as the JSON. And I'm highlighting this because if you hit something with a JSON path, sometimes you will hide more stuff that you want. So be careful with that because it's a slightly different document model, but it works across, right? I showed just 2 examples, but we support almost 40 functions that you can write in the XPath to find the property that you want to use to, let's say, hide the entire parent. You just have to be careful how you're doing this parent-child relationship because the XML is the same, right? It's an attribute in it. But in JSON, you have just to understand. We have many examples in the documentation how to do that. It works really well across both.
I come from a healthcare industry. I'm very excited about the PII and PHI information because we deal with a lot of patient information. I have 2 questions, in fact. The first one is, do you have an idea of when version 3.1 would be released? I know most of the functions that you explained were in 3.1 and not in 3.0. The second one is, I know you talked about encryption at rest. But do you have any thoughts on encryption in motion? For example, the data moving from an S3 bucket to an EC2 node using a MLCP, that's actually going through cloud. Do you have any thoughts on data in movement?
Okay, so let me first answer the first, and to clarify, all the features that I talked about, like element level security, document security, compartment security, redaction, and encryption, are all part of MarkLogic 9. In 905, just added the sets. What he talked about, which was the UI that allowed you to use the UI to protect, is 3.1. But you can already...
You'd find that on GitHub now in a feature branch, and it'll be in our develop branch this week too.
Yeah.
Unless someone rejects my code for some reason.
Yeah.
But actually the entity services feature is in 905 already.
Yeah.
So if you wanted to go around the Data Hub framework, you could already do the PII stuff in there.
And the second question about data moving to an S3 bucket or to another process outside. Then you're going back to my initial problem. You're generating another data silo. So once it's outside the database, if you didn't redact, if you send the document as is, you generate another data silo. So I don't have a solution for you what to do in that case, besides relying on Amazon encryption and using their KMS, right? And then you protect with IAM roles who has access to that bucket. But whoever has access will have access to everything. There's no way to control any granular aspect to that data. So there's some security, but not very granular.
So you've been mentioning role-based access control. I was wondering, like, how MarkLogic is handling role explosion aspect of the RBAC? And also another question is, did you consider ABAC, attribute-based access control? Is that when you reference the element level RBAC, do you mean the ABAC actually?
So let's start with the second, the ABAC. Element level security allows you to do attribute-based, which was the example. Those are attributes, but allows you to have other models as well. So you can fully implement attribute level access control. And going back to the explosion, what you should think about is think about hierarchies of roles. That simplifies a little bit how you would manage roles. And the things that we did with element level security was precisely to try to prevent the explosion of roles. We had customers that, without that feature, they had more than 1,000 roles. And with this, they can simplify. Still a lot, 200, but less than 1,000, right? So the feature helps because you are using attributes and you can use overlapping attributes. That was my example. I had only 3 paths. Think about the combinations if I couldn't do that. So it helps on you decreasing the number of roles. But if you have, as in the example, 180 countries or different groups, you may need 1 role per country. You cannot avoid that. But maybe, for instance, for European Union, it's a block, right? The same policies apply. Maybe you can use hierarchies to simplify a little bit how you manage that. So the feature helps. It does not eliminate the need for having some granularity in the roles. There's a question at the end.
In the example that you present over there, I think you use a Java function. Is it possible to achieve the same result with other solution?
So everything that I showed would work across JavaScript and xQuery. And it doesn't matter if you're doing xQuery or JavaScript. It will work with XML and JSON. So you can keep all JavaScript and protect XML. It will work the same way. So they interop. No problem with that. Just remember, as I said, JSON and XML are not the same document model, and there's no root in one. Think about a little bit what you're hiding and trying to hide, but it will work across JavaScript and xQuery. He showed a more declarative way. He was
Perhaps your question is about, for the API first feature, we're generating Java stubs as a client function, so you can call server-side functions from Java. That's our first client language we're implementing with API first. But if you implement a function that way, it's just a REST call, and you could easily make a call in another language that would do the same thing as the Java does. Or you can tell our product managers, we want some other language, and they'll get that up on the roadmap.
Okay. But important that everything works through REST, so any language that can call REST would work.
Looks like that's a wrap.
Okay, thank you guys.
Thank you, everyone.